Audio Jungle. Audio Jungle.
Hey guys, Marco here from Aviator Live CS. Welcome back to my channel. After being away for a couple of weeks, here I am. I had a technical issue with the computer, which is now solved, and I'm ready to upload our next system. It will be part 3 of air systems, and we are going to talk about pressurization system. As always, a big thank you to Dream Aero for letting me go to the same and get these videos for you. Also, thank you to Captain Pat Moon for letting me use the Boeing 737 MRG app. And today I want to thank Captain Jorge and his amazing Boeing 737 Pro YouTube channel. Captain Jorge has videos there about normal and abnormal situations on the Boeing 737. And I'm going to leave a link in the description below about a couple of these videos that you can use as a reference to support this presentation. Both of them, they are related to abnormal situations on the Boeing 737. So let's keep reviewing these systems together, and I hope you enjoy today's video. Okay, before we start, just remember guys, this presentation is for reference only, and it does not supersede or take the place for any written documents. Okay, so let's start, and before we start with the PowerPoint presentation, I want you to watch the following video where we took in Dream Aero's flight simulator, and we're going to talk there about the lights we have and about the panels we have for the pressurization system. So please go ahead and watch this video.
Let's talk about the pressurization system on the Boeing 737. And first, we will talk about the panels we have. We have the cabin altitude panel here, and here we have the cabin pressurization panel. They are both located in the forward overhead panel. Okay, let's talk about the cabin altitude panel. Here, we see the differential pressure, and we have the cabin altitude indicator. The cabin altitude indicator is the inner scale, and we can see the cabin altitude in feet. And the outer scale is the differential pressure, which indicates the differential pressure between the cabin and the ambient and PSI. Now here we can see the cabin rate of climb indicator. Here we can see the rate of climb of the cabin or the rate of descent. And now we will talk about the altitude horn cutout. And when we push this switch, it cuts out the intermittent cabin altitude warning horn. The altitude warning horn sounds when cabin exceeds 10,000 feet altitude. Now we'll talk about the cabin pressurization panel here. And we'll start with the auto fail light. The auto fail light illuminates when automatic pressurization system failure is detected. Indicates a single controller failure when the alternate light is also illuminated. Indicates a dual controller failure when illuminated alone. To the left side, you are going to see that I'm going to list all the reasons why this light comes on. So if you have the MRG, you can check in the air systems what it says about the auto fail light. What I found interesting here, they have a good explanation about the pressurization controllers. We have 2 of them, and we can read that we have 2 identical pressure controllers, and they operate in parallel to regulate air pressure in the aircraft. The controllers act as master, which is a primary, and a slave alternate. The controller operating as master corresponds to auto. The slave corresponds to alternate. If the master controller recognizes a fault, a pressure control is automatically switched to the alternate mode. here, alternate mode. The auto fail amber light illuminates. The alternate green light illuminates also as soon as the slave has control. Which one is master and which one is a slave depends on a number of factors. The sequence is reversed every flight. Hence, auto fail may not illuminate on the next flight, but reappear on the second next flight. Okay, now we will talk about the off-schedule descent. We can see the light here. The off-schedule descent illuminates amber when the airplane descends before reaching the planned cruise altitude set in the flight altitude indicator. This automatic feature is available in both auto and alternate modes. If you check the MRG, you can read in the off-schedule descent what happens if we have to return to the departure field. The automatic return to takeoff field capability is lost whenever the pilot resets the flight altitude indication. So that's something important to keep in mind. In this case, the cabin altitude may continue to climb or may even descend steeply, resulting in a pressure bump upon touchdown. Now, if we have a diversion, whenever a diversion is made to a field different from the departure field, insert the diversion field elevation in the landing altitude window, which is, you can see it here. In case of a diversion, we need to set the diversion field altitude here. Reset the flight altitude to the current altitude if diversion is initiated before having reached the preset cruise altitude. Okay, now we'll talk about the alternate light. The alternate light illuminates green, and it means the pressurization system is operating in the alternate automatic mode. As we mentioned before, illumination of both alternate and auto fail lights, alternate and auto fail lights, indicates a single controller failure and automatic transfer to alternate mode. Okay, now let's talk about the manual light. This light is green and indicates the pressurization system is operating in the manual mode. In manual mode, each activation of the outflow valve switch will cause an immediate response of the outflow valve. Thrust changes should be made as slowly as possible to avoid pressure bumps. Ambient noise will be a bit louder than usual as door seals are not inflated. The full travel of the valve takes about 20 seconds. The full travel from open to close or from close to open. Electric power to operate the outflow valve manually comes from the battery bus, so we can control it even when standby power is available. The outflow valve position indicator, as you can see here, indicates position of outflow valve, and it operates in all modes. This one is the outflow valve switch, which is spring-loaded to the center position. You can see it has two positions, close and open. In the closed position, it closes the outflow valve electrically with pressurization mode selector in manual mode. So when we go here to manual mode, you can see the light coming on, and then you can control the outflow valve with this switch. In open position, opens outflow valve electrically with pressurization mode selector in manual position, as you can see there. Okay, the pressurization mode selector, as you can see here, it has three positions: auto, alternate, and manual mode. In auto, the pressurization system is controlled automatically. If you move the switch to the alternate position, you will see the alternate light coming on, and then you are controlling the system automatically using the alternate controller. in the manual mode, as we saw before. Pressurization system is controlled manually by outflow valve switch, and both auto controllers are bypassed. Here you can see the cabin flight altitude placard. It's used to determine setting for cabin altitude when operating in manual mode. So here you can see cabin altitude, flight altitude, below flight level 160 and flight level 220, you should have around 2,000 feet cabin altitude. Between 220 and 260, 4,000 feet cabin altitude. Between flight level 260 and 320, 6,000 feet. And between flight level 320 and flight level 410, you will see around 8,000 feet. In the flight altitude indicator, you can see it here. It indicates a selected cruise altitude, and this is set before takeoff. If there is a panel failure detected after a DC power interruption, will result in the display of 8s, a group of 8s here, or all dashes. Flight altitude indicator failure may result in the display of non-numbers or a blank display, which is important to know. Now, if we want to select the flight altitude, we just have to rotate this knob, and then we can select the altitude. Let's say we are going to fly at flight level 270. We select flight level 270 here, as you can see. Now, if we talk about the landing altitude indicator here, it indicates the altitude of the intended landing field, and is set before takeoff as well. Also, panel failure detected after a DC power interruption will result in the display of 8s or all dashes. Landing altitude indicator failure may result in the display of non-numbers or a blank display. So basically the same things for both indicators. Same if we need to select the landing altitude here for the destination, you just rotate, and it has increments of 50 feet, as you can see here. Okay, when we talk about normal operations for the cabin pressurization panel, we'll see the final altitude we'll have for the flight plan. And you can probably see here, in this flight plan, we have flight level 380 as final. 380. So we go to the cabin pressurization panel, and we'll select flight level 380. And then we need to select the landing altitude. And we can check the landing elevation. It's at 204 feet. And then we select this altitude in the landing altitude. 204 will round to 250 feet.
Okay, now we'll start talking about the pressurization system, and we'll start with an overview of the system. To the left side, you can see the cabin pressure control system schematic from the FCON Volume 2. And it says that the air conditioning packs supply pressurization for the cabin. The pressurization system has an outflow valve on the aft fuselage. As you can see here, outflow valve. Cabin pressurization is controlled during all phases of airplane operation by the cabin pressure control system. The cabin pressure control system includes two identical automatic controllers, and they are located in the forward equipment and electronics, or E&E bay, available by selecting auto or alternate. And it also has a manual mode, which is pilot controlled. Something I want to let you know, the pressurization controller 1 is powered by DC bus 1, and the pressurization controller 2 is powered by DC bus 2. The system uses bleed air supplied to and distributed by the air conditioning system. Pressurization and ventilation are controlled by modulating the outflow valve and the overboard exhaust valve. Let's talk about the outflow valve. The outflow valve is the overboard exhaust exit for the majority of the air circulated through the passenger cabin. It is located below the right horizontal stabilizer. It modulates between open and closed position to maintain desired cabin pressure. Now, if we talk about the overboard exhaust valve, on the ground and in flight with low differential pressure, the overboard exhaust valve is open, and warm air from the E&E bay is discharged overboard. In flight, at higher cabin differential pressures, the overboard exhaust valve is normally closed and exhaust air is diffused to the lining of the forward cargo compartment. However, the overboard exhaust valve is driven open if either pack switch is in high and the right recirculation fan is off. Remember, we talked about these fans in the previous videos. This allows for increased ventilation in the smoke removal configuration. Now, if we talk about the pressure relief valves, okay, let's talk about the pressure relief valves. And we have two pressure relief valves provide safety pressure relief by limiting the differential pressure to a maximum of 9.1 psi. And remember, that's a limitation we saw at the beginning of these videos. A negative relief valve prevents external atmospheric pressure from exceeding internal cabin pressure. Cabin pressure controller. Cabin altitude is normally rate controlled by the cabin pressure controller up to a cabin altitude of 8,000 feet at the airplane maximum certified ceiling of 41,000 feet. So the cabin pressure controller controls cabin pressure in the following modes. And this is an exam question. Just pay attention to this, please. Auto is automatic pressurization control. Is the normal mode of operation and uses VC motor. Alternate, automatic pressurization control, the alternate mode of operation and uses DC motor. Man is the manual control of the system using VC motor. The air data inertial reference units, ADIRUS, provides ambient static pressure, baro corrected altitude, non-corrected altitude, and calibrated airspeed to both automatic controllers. The ADIRUS receive barometric corrections from the captain's and first officer's baro reference selectors. The automatic controllers also receive throttle position from both stall management computers and signals from the air-ground sensors. The air-ground safety sensor signals whether the airplane is on the ground or in the air, and this is important to know. On the ground and at lower power settings, the cabin is depressurized by driving the outflow valve to the full open position. The cabin begins to pressurize on the ground, and this is an exam question as well, at higher power settings. The controller modulates the outflow valve toward close, slightly pressurizing the cabin. This ground pressurization of the cabin makes the transition to pressurized flight more gradual for the passengers and crew, and also gives the system better response to ground effect pressure changes during takeoff. The cruise mode is activated when the airplane climbs to within 0.25 psi of the selected flight altitude. So you can see the table here, and here you can have a reference So if you have selected a flight altitude at or below 28,000 feet, the differential pressure limit should be 7.45 psi. Between 28,000 feet and 37,000 feet, the differential pressure limit is 7.8 psi. And above 37,000 feet, the differential pressure limit is 8.35 psi. Now, the descent mode is activated when the airplane descends 0.25 psi below the selected flight altitude. The cabin begins a proportional descent to slightly below the selected landing altitude. The controller programs the cabin to land slightly pressurized so that rapid changes in altitude during approach result in minimum cabin pressure changes. While taxiing in, the controller drives the outflow valve slowly to the full open position, depressurizing the cabin. So this is very important to know. Now we will talk about some abnormals in the pressurization system. And in the video, we talked about the off-schedule descent light and why it comes on. And we also talked about the auto-fail and how it works. Now here I want to show you a couple more of abnormals. It's the cabin altitude warning, which is very important to know, and the emergency descent. For the off-schedule descent, and this is this next slide here, I want to show you the QRH, what it says. As you can see the light there, and the condition is that descent is started before reaching the planned cruise altitude, setting the flight altitude indicator. And then you can choose one, the landing at airport of departure, continue normal operation, not landing at airport of departure, flight altitude indicator, reset to actual airplane altitude. And we talked about it in the video. Now we will talk about the auto-fail light. The normal checklist says auto-fail or unscheduled pressurization change. And it says the auto-fail light may or may not be illuminated. Condition: one or more of these occur. Automatic pressurization mode has failed. The cabin altitude is uncontrollable. And the objective is to maintain control of cabin altitude. And number one, increasing thrust may ensure sufficient air supply to control cabin altitude. Step 2, pressurization mode selector alternate. Remember, we saw that in the video. Number 3, choose one, auto-fail light is extinguished, and cabin altitude is controllable, and then we will continue normal operation. The other option we have, auto-fail light is illuminated, or cabin altitude is uncontrollable. Then we'll go to step 4. Pressurization mode selector to manual. Okay, we'll go to step 5, outflow valve switch, move to open or close as needed to control cabin altitude and rate. And we have this comment here, use momentary actuation of the outflow valve switch to avoid large and rapid pressurization changes. Number 6, choose one, cabin altitude is controllable, go to step 11, which is checklist complete except deferred items. The other option is cabin altitude is uncontrollable. We go to step 7. Now, before we go to step 7, if you have the MRG and you go to cabin altitude warning or rapid depressurization in air systems, there is something good to know. And it says that it may be very hard to distinguish a full-scale cabin rate of climb from a full-scale cabin rate of descent. So imagine this needle here, here, or here. Remember that the full-scale cabin rate of climb means that the cabin is out of control, and the full-scale cabin rate of descent means that the cabin pressure is recovering. Both indications look almost the same. Furthermore, with the cabin out of control, once inside and outside pressure are equal, cabin rate will simply indicate the aircraft rate of descent. You have to monitor the cabin differential pressure, which is this outer scale. The big needle should remain above 4 psi. So it should be above this indication here, 4 psi. If the big needle drops below 4 psi, we can consider the cabin out of control. All right. Now let's go back to the non-normal checklist, and I just wanted to talk about the cabin controllable or uncontrollable in step 6. Now remember, if cabin altitude is uncontrollable, we go to step 7, which says don oxygen masks and set regulators to 100%. Establish crew communications, passenger signs on, passenger oxygen switch on. And then we go to the emergency descent checklist, which we'll review in the next slides. We continue with the descent checklist for the auto fail. It says pressurization, move auto flow valve switch to open or close as needed to control cabin altitude and rate. At pattern altitude, it says outflow valve switch, move to open until the outflow valve indication shows fully open to depressurize the airplane. And then we have the landing checklist. Okay, now we talk about the cabin altitude warning. And I know that new airplanes, they have red warning lights installed on the captain's and first officer forward instrument panel. And they illuminate when the cabin pressure altitude exceeds 10,000 feet. Just remember that the cabin altitude warning horn and the takeoff configuration is the same. It's the same sound. Okay, before we continue reading the non-normal checklist for cabin altitude warning or rapid depressurization, I just want to mention something about rapid decompression and slow decompression. In the rapid decompression, we could have an outflow valve malfunction, we could have a door opening, or it could be caused by structural damage like a bomb explosion. And if we talk about the slow decompression, it could be caused by an outflow valve malfunction, pressurization controller fault, incorrect pressurization setup, door seal damage or missing, or maybe a toilet flush valve jammed open. All right, so now let's go to the cabin altitude warning or rapid depressurization non-normal checklist. Condition: one or more of these occur: a cabin altitude exceedance. In flight, the intermittent cabin altitude configuration warning horn sounds, or a cabin altitude light if installed and operative illuminates. So what we have to do first is we need to don the oxygen masks and set regulators to 100%. We need to establish crew communications, pressurization mode selected to manual, outflow valve switch, hold and close until the outflow valve indication shows fully closed. Remember, we said that the full throttle takes about 20 seconds. If cabin altitude is uncontrollable, passenger signs on, pass oxygen switch on, and then we need to go to the emergency descent checklist, which says emergency descent non-normal checklist. Condition: one or more of these occur. Cabin altitude cannot be controlled. A rapid descent is needed. So we need to announce the emergency descent. The pilot flying will advise the cabin crew on the PA system of impending rapid descent. The pilot monitoring will advise ATC and obtain the area altimeter setting. Passenger signs on. Without delay, descend to the lowest safe altitude or 10,000 feet, whichever is higher. Engine start switches both continuous. Thrust levers both reduce thrust to minimum or as needed for any ice. A speed brake, flight detent. We check this note: if structural integrity is in doubt, limit the speed as much as possible and avoid high maneuvering loads. Set target speed to MMO, VMO. But just remember this note. Step 8, when approaching to the level of altitude, smoothly lower the speed brake lever to the down detent and level off at the thrust and stabilize on altitude and airspeed. Crew oxygen regulators normal. Flight crew must use oxygen when cabin altitude is above 10,000 feet. To conserve oxygen, move the regulator to normal. Engine start switches both as needed. The new course of action is based on weather, oxygen, fuel remaining, and available airports. Use of long-range cruise may be needed. Okay, that's the end of the checklist. And for these two situations, cabin altitude warning and rapid depressurization, Captain Jorge has in his YouTube channel, Boeing 737 Pro, a couple of videos which are very useful to see how the emergency send is done and how to deal with this cabin altitude warning. I encourage you to go there and watch those videos. They're going to be very helpful, and they're going to help you understand how this is completed. Alright guys, that's the end of the presentation for today. I hope you liked it. If you did, please give me a thumbs up. And if you're not subscribed to my channel, please do it now and hit the bell so you will know once I upload a new video. If you think these videos are useful for somebody else, please share them. And that's going to help me a lot to grow this channel. I hope to see you guys next week when we upload the next system. Until then, please take care and see you soon.